So I'm just going to teach this a little bit different. All you're going to do is just sit here. I promise. I'm going to give you time. I have everything written down that you need to write down, and I'll give you time at the end to write it all down. Okay? But I just want you answering my questions and telling me what you think. I want you to participate. Okay? I want you to participate. So all we're going to do is we're going to learn how to graph absolute value equations. Okay? Now you know if you graph an absolute value equation, what does it look like? A V, okay? Y'all listen to me. Every time you graph an absolute value equation, it looks like a what? A V. If you graph a V, it's an absolute value equation. Do you understand that? There's going to be some of them on the test. I don't know. Let's say there's 5 of them on the test. I really don't remember. I'm just making that number up. Okay? Let's say that there's 5. There's going to be some people, and they're going to miss every one of them. Because they're going to draw a line. I'm like, oh my gosh, where were you? How many times did we say that? All right? People, if you're graphing an absolute value equation, it better look like a what? A V. Okay? So what I'm going to do is, remember where absolute value is on your calculator? You can go second in catalog, but I'm going to go alpha and F2. Okay? So alpha and F2, and it's the very first thing that comes up. You can see some things that are marked out. Some of the kids are like, whoa, why is that marked out? It's marked out because it's not a legal calculator skill for an Algebra 2 kid. Okay, so if they have something in Algebra 2 that we teach, and you can't let your calculator do it for you, then they will take that off of the calculator. So that's why it's marked through. So I'm going to choose number 1, and I'm just going to graph the parent function. Okay, I'm going to go zoom 6 because that's a standard 10 by 10. Okay, and oh, stop. Sorry.
That was cool.
Yeah, well, dang it. Stealing my thunder. I'm not good at this calculator. Okay, so here it is. This is what I want. I'm also going to tell you that you already saw I did that. But anyway, I went second in format right here, and I turned my grid on. Okay? So all that does is, instead of being squares, it's just dots. But it allows us to count things, like you could count slope a lot easier with the grid on than you could with it off. Okay? So I'm going to graph it now. And there's your parent function. Okay, you see it? All right, you can tell that the vertex of the graph is at 0, 0, right? You can count the slope. You can go, he goes up 1 and over 1, up 1 and over 1, up 1 and over 1. On this side, he does the same thing. Up 1 and over 1, up 1 and over 1. And goes on and on, okay? Now, what if I go down here and I go, the absolute value of x minus 3, okay? What if I did that? All right, now look, I don't want you writing anything down. I don't want you working on another worksheet. If you're working on a worksheet, I'm gonna take it up and throw it away. You're not gonna be very happy with me, okay? So put it up. You're not supposed to be writing anything down. You're just supposed to be paying attention. So what do you think that's gonna do to that graph? Change it how?
Go down, I guess.
Go down, go down 3, okay? Anybody else got any thoughts? No? Y'all just think, y'all think it's gonna go down 3? All right, let's graph it and see.
Shifted 3. It's 3 attached.
Oh, Cole's on to something, okay? Cole's on to something, he's thinking, all right? I like the way, Anaya, that you said it's gonna go up 3, because a lot of kids will think, no, it's not gonna go down 3, it's gonna go up 3, because it's in an absolute value, right? Okay, so some kids think that, but we saw that it didn't go up or down any, it went right. Did it go right 3? 1, 2, 3, it went right 3. Well, that's kind of weird, But let's use that thought and see, what if I said plus 5? Now, seeing what you saw, what do you think this is gonna do? Go what? Go right 5? Go left 5? Someone said right 5, someone said left 5?
I don't think it'll go left.
It won't go left because that'll be
Because it's a
right.
negative. Absolute values don't do.
Why would it go left? You can't have a negative.
Okay, how many did it go left? 5.
If negative goes right, then positive has to go left.
Oh, okay. So, so if that's true, let's just check our theory, okay? Then if I say minus 2, what should it be doing?
Right.
Let's see. Boom. Okay, and let's check it and make sure. Let's go, what, plus 3 or something? Okay, so tell me what you figured out.
If it's positive, it goes left, and if it's negative, it goes right.
Okay, so if it's plus, it goes left, and if it's minus, it goes right. Do you agree with that?
Yes.
Okay, so let's do something different. Let's take this problem right here, and let's go outside the absolute value. What you think that's gonna do? Go left 3? Flip it? Maybe. Parent function? What'd you do?
It's outside of the absolute value.
It's outside the absolute value, okay? He moved it down 3, which means that I probably can assume that a plus 5 is gonna make it do what? Go up 5. Okay, all right, so let me ask you a question, okay? That was pretty good. Y'all did a good job. So if I add or subtract something inside the absolute value, which way does it move?
Horizontally.
Yeah, horizontally, left or right, okay? Hang on just a second, I'm gonna shut this door. Okay, now that makes sense, right? Because if it's inside the absolute value with an X, guess what? He is an X, all right? And which way does the X-axis move? Horizontally, left and right. You agree? Okay? If it's outside the absolute value, which way does that move? Yeah, vertically, up and down. Kind of like a Y goes up and down. Okay, if it's inside the absolute value, it goes left or right. How does it go left or right?
Keep adding, subtracting.
It goes the opposite of its sign, the opposite way that you thought it would go. Do you agree with that? Okay. What about outside the absolute value? Is that opposite? No, that was just like you thought it was going to be, right? One of them went, the minus went down and the plus went up. Okay, so if that's true and you know all of that stuff, okay, then could I just put an equation in here? And should you know exactly where it is?
Yes.
Do you agree with me? Okay, so this minus 2 makes it go where? To the right 2. This plus 3 makes it go
Up
3. So let's graph it. Let's see how good we are.
This little vertex in this 2, 3,
Yes, exactly, Ace. His vertex is 2, 3 because he moved right 2 and up 3. So now his vertex is 2, 3. Very good. All right, everybody got it? Do we need to try one more? So left 1, 2, 3, 4, and down 1. Okay? Very good, very good. All right, so let's do something else. How would I make that equation flip upside down?
Put a negative outside the absolute value.
Put a negative outside the absolute value. Well, let's see. Negative absolute value of x. Did it flip it exactly? Well, we can go back here and we can put the parent function back up there, right? And you can see, did it flip it exactly? Yes, it did. You see how that's a straight line right there and that's a straight line? Okay, I don't like the word flip because that's not a very mathematical term, okay? But it reflected it over which axis? The x-axis, very good. There's the parent function, and if you reflect it over the x-axis, then it flips it, reflects it down here where it opens down. Okay, so what would happen if I put a negative on the x inside the absolute value? I'm gonna tell you this, okay? When you put this negative, y'all listen to me. Remember the other day when I told you to be careful that x's go with x's and y's go with y's? Okay, so that's why a number that's inside the absolute value with an x, he is an x. He moves it left or right, opposite of what you think, okay? A number that's not inside the absolute value with the x, if he's not with an x, then he has to be a what? A y. You're either an x or a y, okay? So if he's not in there with the x, he's outside, then he has to be a y. Y's may not necessarily be with a y, but if they're not with an x, then they're a y. So this negative that's outside here, would that negative be on an x or a y? Yeah, he is on a y, all right? And so notice what I said he does. This negative is on the y, he reflects it over the x-axis. What if I went down here and I put a negative on the, let's see, I'm gonna change something. I'm gonna clear these. I'm gonna put the parent function back up there. Sorry. There's the parent function, okay? So I'm gonna put the x, I'm gonna put the negative on. Now notice, I used this negative sign down here, I did not use the minus sign. Okay, if you use a minus sign, it's gonna tell you have syntax error. Alright, you have to use the negative sign. So I put the negative on the x. If that negative is outside and he's on the y, he reflects it over the x-axis. If the negative is on the x, he's gonna reflect it over the y-axis. What's it gonna look like?
Greater than or less than.
Here's the parent function. And here's the reflection.
Oh.
Oh. Yes. Okay, so now look, let me show you something. Look what happened. Here's the y-axis, do you agree? So if I reflect this side over the y-axis, all he does is what? Flip to this side. And if you reflect this side over the y-axis, what does he do? He just reflects over here. So it looks like nothing really happened. I reflected it. Remember, to do a reflection, I can fold it on this thing, okay? And then like I could fold it on the x-axis and fold it over, and where it would be, that's its reflection. Okay, so if I folded this on the y, this side's gonna land on this side. This side's gonna land on this side. So he just looks the same. Okay? But you do need to know this, that if you put a negative on a y, it reflects it over the x-axis. If you put a negative on the x, that reflects it over the y-axis. That's gonna come back up again in our next test. Okay? Not this test, but the next test. That's what this, when I do something inside here on this x, that's one of the most difficult skills that you're gonna learn. Alright? That's one of the most difficult skills that you're gonna learn. Okay, so let's go down here and let's clear that guy out. We're through talking about him for a while. What if I, how could I make that V skinnier? How can I make that V skinnier?
Number in front of the X.
Put a number in front of the absolute value. What kind of number?
A number bigger than,
A big number or a little number?
a number less than zero?
A number less than, no, that's just gonna be a negative. All that's gonna do is flip it down, right?
I mean, a number less than zero, between zero and one?
A number between 0 and 1. Okay, so let's do that. Let's put 1/4. Okay, and go absolute value of x. So I'm doing 1/4. Here's my parent function. And here's 1/4.
Oh, really wide.
Yeah, did that make it skinnier?
Uh-oh.
It made it wider. Okay, what am I affecting? Is what? Is what? Yeah,
Round
his-
number one.
his slope, yeah. Y'all look, you remember this, what's the slope of this guy? It's 1, it's up 1 and over 1, up 1 and over 1, up 1 and over 1. What's the slope of this guy? 1/4. Yeah, so what?
4/1.
4/1, yes. So you go up 1 and over 4. And you go to the left 4, because it's symmetrical, right?
Yes.
So that's what it's slope of. All right, so,
It has to be a number bigger than one.
oh, that's right. So that's why Carson said, instead of 1/4, just do 4/1 or just 4, right? So let's do this one. Now, should this one be? Here's the parent function. Oh, yeah, he's a lot skinnier, right? Because look at his slope. He's going up 4, 1, 2, 3, 4, and over to the right one and to the left one. And then he does it again. Up 1, 2, 3, 4, and to the right one, and then you would count here and go to the left one. Okay? Good job, good job. All right, so let's talk about this number for a second. Okay, so this 4 right here, is this 4 on an X or a Y?
Wow.
He's on a Y, right? Because he's not inside there with an X. Y'all, if he has to be inside with an X or in parentheses with an X in order to be affecting an X, okay? So he's a Y. So now, did Y's do what we thought, or were they like weird and did the opposite? They did what we thought. Pluses moved up and minuses moved down. So this guy's gonna do exactly what you think. He's 4 times, okay? He's a stretch. He vertically stretched something. If you vertically stretch something, what's gonna happen to it? Is he gonna get skinnier or fatter? Skinnier, okay? That 1/4 was what we would call a vertical compression or vertical shrink. And if you compress something, it gets wider, right? So that's why he got wider. So what kind of numbers are gonna make a vertical stretch? Numbers that are what? Bigger than 1. And numbers that are a vertical compression are gonna be between 0 and 1. All right? You can't say less than 1 because we don't really wanna think about the negatives. All right? Because all the negative does is make it open down instead of up. All right? Anybody got a question? Everybody okay? All right, so let's see. If I cleared out all this mess and I put an equation up there, let's see if you can. How many points do you think I want on your graph?
3.
3, very good. Because 3 is going to tell me that you know where the vertex is and what the slope of it is. Do you agree? Okay, so I want you to jot down a little thing. We're just going to try 2 of them. Okay, yeah. Just jot down a little graph somewhere. All right, I don't care. I'm not taking it up or anything. But I'm going to ask you to graph this one, and I want 3 points on it. If you don't have 3 points on your graph, people, then you lose points. Everybody understand? Okay, so here we go. Two times the absolute value of x plus 3 minus 1. I want you to graph it. 3 points. Okay, you got it? All right. So just tell me what the 2 does to it.
It makes it steeper.
Yeah, it makes it steeper, it makes it skinnier, right? Okay, what does this plus 3 do to it?
It makes it go to the left.
To the left. So I started here at my origin and I went 3 to the left. 1, 2, 3. What does this minus 1 do to it?
It makes it go down. Like, it, up and down, so since it's a negative, it goes down.
Okay, so there it is right there. How does my V open, up or down? Why?
There's not negative out.
Yeah, because that's just a positive 2. His slope is 2, right? So from here, I'm going to go up 2, and to the right 1, and to the left 1. And there's my V. I missed it, sorry. Anybody got a question? Here's what yours should look like. People, is there any reason in the world why you should miss these problems on a test?
No.
I mean, and why would you even draw a line? Good night. Pop that thing in a calculator and go, oh, how stupid am I? Okay? Stop. Come on, this is easy stuff. All right, we're going to do one more, and then we're just going to write all our stuff down. Okay, so I'm going to clear this guy out, and I'm going to go. Okay, I want you to graph him on your little graph that you have right there. All right, are you ready? Okay, so I'm just going to go through and talk about everything first. What does this minus sign do? Yeah, makes them up and down. What is this 1/2?
That's a slope.
That's my slope. So now my V is going to be what?
Wider.
Wider, okay? And what does this minus 3 do?
Move it to the right.
And what does this plus 4 do?
Moves it out.
Okay, so I'm going to go right 3, 1, 2, 3, and up 4. 1, 2, 3, 4. So there's my vertex, okay? From that vertex, I need 2 other points. I'm going to use my slope. He's opening down, so I'm going to go down 1 and to the right 2, and down 1 and to the left 2. And here's my V. You could graph it on your calculator and check it. All right, anybody got a question? Everybody okay? Okay, I'm gonna ask you one question, and remember this. This is the most difficult skill, okay? What would happen if I took that equation of this graph right here and I put a negative on the x? What would happen to that graph?
It would, you just said it. It wouldn't move.
Where would it move?
It would just flip it to the y-axis.
Flip it where?
It would reflect.
Reflect it through the what?
X-axis.
No, y-axis.
Okay, so then instead of being over here, where's he gonna be?
On the side.
Yeah, he's gonna be over here, okay? He's gonna be over here. He still moves all that same way, but that negative is gonna take this vertex and reflect it through that y-axis, and he's gonna be over here, all right? So I wanna show you that. Sometimes that's the thing that really messes with kids' heads. So I'm gonna insert a negative in front of that x, just like that, and watch what happens to my graph. Remember, he was looking like this. All that did was instead of being 3 to the, he still went 3 to the right and up 4, but now he's over here, okay, and going down. All right? One more thing, I'm going to put one in here, and I'm not going to show you what the equation is, and I want you to tell me what the equation. I'm going to give you the graph, and you're going to write the equation, okay? All right, you write the equation. All right, you ready? So, y, where are we? Here we are. Y is equal to, what's the first thing I need? Negative, okay? I need a negative, right, because he's opening down. So what's his slope?
3 of 1.
There you go, okay? Y'all listen to me, if that had a slope of 1/3, what would this V look like? It would be very wide, okay? So slope is rise over run, so the negative is making it go down. But do you see how you count? Stop that. You see how you count 1, 2, 3, and to the right one, and to the left one? And sometimes you're like, I'm not really sure, so do it again. 1, 2, 3, over 1, okay? If you were off, was my pen off when I did that? Oh, sorry. It's not off on my thing. I don't know that I can do it up here. So 1, 2, 3, and to the right one, and then 1, 2, 3, and to the right. You see what I'm saying? If you're off, then every time you do it, you'll be off even more and more and more. So it'll show more. So if you're unsure about it, keep on doing what you guess. So that's a 3. Absolute value. Where did he move? Left or right?
Right.
No,
left.
Left. How do you make him move left?
Plus 4.
So plus, how many did he move left?
4.
4. And then did he move up or down?
Down.
And how do you make him move down?
-2.
So -2. So that should be my equation. So if I looked at it, you can see, there it is. Y'all are perfect. All right, anybody got a question? Everybody good? Okay, so now we want to write all this stuff down, right, so that we know it. So I'll pull this back up here. I'll let it focus for a second. And then I will set Alright, so this is what you need to write down. So this is section 2.7, and it's absolute value equations. Okay? You know that the parent function is y is equal to the absolute value of x. My domain is from negative infinity to positive infinity, and my range is from 0 to positive infinity. Alright? We are skipping example 5. I'm telling you that in case you use your book, or whenever you take pictures of the chapter review and the chapter test, they may have problems that are like that, example 5. You don't want to do that. If you run into a problem and it looks weird to you, then we haven't done that yet, so don't do it. All I've asked you to do is, can you graph it without your calculator, and can you write an equation for one? Okay? I don't mind if you check it on your calculator. I think that's a good thing to do. Alright, so here's the first thing that y'all told me. If it is with an x, it is an x, and it moves left or right opposite of what you think. And y'all even use those same words, okay? Y'all even use those same words. I'm trying to make this go right without making you sick. But okay, if it is with an x, it is an x, and it moves left or right opposite of what you think. Y'all listen to me. These rules that I'm telling you, these are the rules for everything. I don't care what you're graphing. It is the rule. If it is with an x, it is an x, and it moves left or right opposite of what you think. Y'all, look, I even showed them our trig stuff, okay? I even showed them our trig stuff. So, like, look, I'm going to show you. This is a sine curve. This is the way a sine curve looks, okay? And so, normally a sine curve starts right here, but this one has been shifted right, pi over 4. Look at the equation, minus pi over 4. See? Pretty cool. Pretty cool. Very neat. Alright, so x's are weird, but guess what, people? They're always weird. They're always weird, and everything that they do is weird. That's fixing to come back up. Alright? If it is not with an x, it is a y, and it moves up or down just like you think. So that number may not exactly be with a y, because a lot of times when we graph stuff, we solve for y. But if it's not with an x, then you go, oh, that has to be a y, because he's not with the x. If he's with the x, he either has to be in parentheses with the x, or he has to be in a symbol. Like in this case, he's in the absolute value symbol. He could also be under a radical, like a square root function. He could be in parentheses and quantity squared, like a quadratic. All those things. So if it's not with an x, it is a y, and it moves up or down just like you think. All right, so this is talk about vertical and horizontal stretches and compressions. We talked more about the vertical ones than we did the horizontal ones, but the horizontal ones are going to be the same, except that if it's with the x, he's going to be opposite of what you think, okay? So this is what a vertical one does. The number in front of the function and multiplied by the function is a y, okay? He's not inside something with an x, so he's a y. That's what's making it a vertical stretch or compression, all right? And they do exactly what you think. I took the absolute value, we call that number A, all right? Look, I'm going to show you this. Even in trig, y'all, see, I want you to know that the stuff you're learning right now, you're going to use that later on, okay? Look, even in trig, there's my sine and cosine function curve. Look, there's that A. This is the number that's either taken that curvy graph that I showed you and either vertically stretching it and making it go up really tall and come down really low, or he's compressing it and making it barely go up and barely go down and barely go up. Okay? It's still the same number. It's still the same thing. It's A. That's going to be that vertical stretch or compression. All right? So I don't wanna talk about the sign of the number, so I just took its absolute value. If A is greater than one, like if it's 2 or 3 or 4/3, which is 1 1/3, right? Then that's gonna be a vertical stretch. You could think about it, like if you were two times as tall as you are now, that would be a vertical stretch, right? You would look skinnier. The same way with that V, the same way with that sine curve stretch. He's gonna look a lot skinnier, okay? For a compression, that number has to be between 0 and 1, all right? That number has to be between 0 and 1, and that's gonna be a compression. We used to call it a shrink, but about 4 or 5 years ago, they started using the word compression, and now you see the word compression a lot more. You seldom see shrink unless it's an older book. Okay? And then this one says that if you have a number in front of it multiplied by the x, he's a weirdo. He's gonna do the opposite. Okay? So he's gonna be a horizontal stretch if the number is between 0 and 1, and he's gonna be a compression if the number is bigger than 1. He does just the opposite. And then I wrote down there in a different color that sometimes a horizontal stretch will look like a vertical compression, because a horizontal stretch is gonna make it wider, right? So when you compress something vertically, it makes it appear wider too. All right, everybody got that written down? Almost? So that's all of 2.7. That's gonna be everything in 2.7. And now we're gonna do 2.8. And 2.8, you already know how to do. I'm gonna show you a little shortcut. You know, in Algebra 1, we don't teach any shortcuts, but sometimes in Algebra 2, we kind of assume that kids have things a little bit better, so we teach them sometimes some quick ways to do something. Okay, now we're gonna do, we're gonna start on 2.8. So 2.8, we are going to graph linear title, first of all, I'm like, okay, so we're graphing something on a coordinate plane, all right? What does linear mean? Line. So I'm thinking that they're all gonna be lines. I'm gonna tell you now that one of them's not gonna be, okay? But I think you'll be okay with it. And then, what is that?
Less than or greater than?
Okay, so instead of having an equal sign, have we graphed linear equations before? Yes. Okay, so these are gonna be linear inequalities, so they're gonna have greater than or less than signs. Here's what that means. That means that you're gonna have to graph and shade. Remember that? Okay, so first of all, you're gonna have to decide, is your line solid or dotted? And then you're gonna have to decide which side to shade. All right, so before I get to a problem like that, I want to work one like this. Cause I think these should be easy problems, and I want you to know how to do it, okay? So, example 1, which ordered pair is a solution of 2x plus 5y greater than 9. Which ordered pair is a solution of 2x plus 5y equals 9? All right, so here's my question. If it is a solution, what kind of statements do solutions make? What kind of statements do solutions make? If it's a solution, will it make a true statement or a false statement?
True.
A true statement, okay? So I'm looking for things that make true statements. If they don't make a true statement, it's not a solution, okay? All right, so here's my first one. -4, -1. Now what am I gonna do with that?
Plug in.
Yeah, I'm gonna plug it in, and what am I looking for?
If it's greater than 1.
Yeah, I wanna know, is it gonna make a true statement? So I'm gonna say 2 times -4 plus 5 times -1 is supposed to be greater than 9. All right? Now look, people, if this was a test, what would I do right now?
Cross that out.
Use calculator.
I would pick my calculator up, I would say 2 times -4 plus 5 times -1, bam, and I would say, are you greater than 9? Yes, circle it. No, cross it out and move on to the next one. Okay? Do you see what I'm saying? If it's not a test, then I'm gonna work on my multiplication facts, okay? What's 2 times -4? What's 5 times -1? These are like signs. What do you do with like signs? And 8 and 5 make what? 13? And the sign of both is negative. -13 is greater than 9. True or false? False. It ain't A. Okay? Let's try B. B is 2 -4. You try it. Okay? B is 2 -4. If you want to know if something is a solution, plug it in and see if it makes a true statement. -16 is greater than 9. True or false?
False.
Well, and then B. So, what about C? What'd you get? 11's greater than 9. True or false?
True.
Okay? Anybody got a question? So if I gave you something like that on a test, could you work that problem? Even if it's Friday, are you still gonna be able to work the problem?
Yes.
Okay? People, look, you're done with the time where you can learn something and then forget it. Okay? Everything you learn, you're going to use in this class. Alright? So don't learn something and then just forget it. Alright, so here we go. Let's do example 2A and 2B. We're gonna be graphing, so I'm gonna draw me one graph. I'm gonna do both of them on the same graph. So I'm gonna draw me a little 6 by 6. That should be plenty big enough. Okay? Alright, so here's the first one. This is 2A. Negative 2y minus 5 greater than or equal to 1. If I'm gonna graph this, what do I have to do first?
You need to add 5.
Yeah, solve for y. So I want you to solve for y. Okay? I want you to solve for y. Alright, let's see how good you did. So, yes, like Jaden said, we're going to add 5 to both sides. Okay? I'll get negative 2y is greater than or equal to, what's 1 and 5? 6. Now what am I going to do?
Divide by 2. Negative 2.
Okay. Oh, ding, 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 ding.
Oh, you switch your sign.
Oh, anytime you multiply or divide by a negative, you have to flip the sign. So, now we already learned that this year, right? Okay, what is 6 divided by negative 2? Negative 3. Okay, so, whoa, wait, this looks weird. I don't have an X in it. What kind of line is this?
Oh, it's gonna be a horizontal.
Oh, that Y looks like an upside down H. That's a horizontal line. Where?
On negative 3.
On negative 3, on the Y-axis, guys. On negative 3. So here it is. Is it solid or dotted?
Solid.
Solid.
Solid. Why?
Because it's greater than or equal to.
Or equal to. If it has this line underneath it, then that means it's solid. If it doesn't have the line, that means it's dotted. Solid means the line is included in my solution. Dotted means it's where it's shaded up until you get to the line. Okay? So here he is, a solid line. Okay? Now look, read this, read this. I want the y's that are less than negative 3. Would that be above the line or below it?
Below.
Below. Y's are less than negative 3, that's below. Anybody got a question? Do y'all remember this?
Yes.
Okay, what about this guy? Here's yours, your next one. This is 2B. Or not 2B. Okay, so you should have divided by 3, right? You try to solve for for y, but there is no y. So that means you need to solve for x, okay? So x is less than 1. All right? So, what kind of line is this?
A vertical.
A vertical line where x is 1, right? So that would be right here. Solid or dotted?
Dotted.
Okay, if you're like me and you forget to do that, you're gonna need a big eraser, okay? Because you're gonna have to go back and erase some stuff,
Oh, crap.
all right? I want the x's that are less than 1. So would that be to the left or to the right? Anybody got a question? Okay, so we're gonna do 3. He's gonna have 2 examples and we're gonna graph them. So I'm gonna draw me another graph. I'm gonna make a 7 by 7. Okay, and we're gonna do this one. I'm gonna do this one with you because I want to show you something, okay? So y is greater than negative 2x. Y is greater than negative 2x. So the first thing I'm gonna do is I'm gonna solve for y. Well, that's already done. So then I'm gonna write my slope and my y-intercept. Have I asked y'all to do that?
Yes.
Okay, I like it when you do that. I like it when you write your slope and your y-intercept. What is my slope? Negative 2. What is my y-intercept? 0. I like it when you write that because I think you're much less likely to make a mistake if you're writing stuff and thinking, okay? It's not hard to do, and so you can do it and it makes you feel really good because you're like, wow, I know how to do this, all right? Y-intercept is 0. I'm going to tell you this. Sometimes when you do things, I say, I like it when you do this. Do I reward you for that? Okay, you might want to pay attention. All right, my y-intercept is 0, so I go to 0, and then I'm going to use my slope. Okay, my slope is negative 2. So where am I going to go from here?
Down, you can either go down to.
I'm going to go down 2 and then to the what?
Left
To the
one.
right. I always run to the right if I can. Okay, I'm gonna work one that where it's not gonna work out so well for me, but I'll show you what we do. And then I'm gonna do it again, cause I like 3 points, right? 1, down 2, and over to the right 1. All right, and then what are you supposed to ask yourself?
Is that 3 points?
Yeah, 1, 2, 3. All right, and is it what?
Is it dotted or?
Yeah, is it solid or dotted? What is it?
Dotted.
It's dotted, okay? So if you've already drawn it and you made it solid, you need to pull out that old eraser,
I'm already committed to this other thing. Just put a dot on my name.
okay?
Yeah.
So now, look, I'm gonna teach you, first of all, I'm gonna show you how you learn how to do it in Algebra 1, okay? Just like I told you, in Algebra 1, we don't ever do shortcuts, okay? So in Algebra 1, you were taught to graph the line, and then you pick a point that is not on the line, all right? You can pick any point that you want to. I'm gonna pick the easiest point that's not on my line. So I'm gonna pick this little point right here, 1, 1, okay? So 1, 1. I'm gonna plug him back in here. If he makes a true statement, then every point on this side makes a true statement, and that would be my solution. If he makes a false statement, I would shade the other side, okay? So 1, 1. Y is 1 greater than negative 2 times 1. 1 is greater than negative 2. And that's true, right? So I shade this side over here. All statements on that side make true, or all points on that side make true statements. Now I'm going to show you how I do it, okay? This is the way I do it. I put my finger where that line crosses the y-axis, and then I read what I want. I want the y's that are greater than. The y's that are greater than, would that be above my finger or below my finger? And so that I would shade on this side of the line. Do you see what I'm saying? Okay, here's yours. You're going to try this one. All right, are you ready? 5x minus 2y less than or equal to negative 4. 5x minus 2y less than or equal to negative 4. tell you this, if you'll write your steps and show your work a little bit, it will keep you from making careless mistakes. Is this what y'all got? 5/2 x plus 2, y is greater than, did you flip your sign? Good, you think I'm gonna test that on the test?
Yes.
Probably am. My slope, did you write your slope and your y-intercept?
Yes.
Okay, so my y-intercept is 2. Where does the y-intercept go?
On the Y line.
On the y-axis. What's gonna be the common mistake?
I guess put on the X.
People put it on the x-axis. They did it on that last test, guys. People put it all over the x-axis. It was never going to be right. Okay, well, I'll take it back. The only time it will be is when it's 0. All right? But other than that, it's not right. So if it's a y-intercept, it belongs on the y-axis. So my y-intercept is 2. So I'll put me a big dot. All right? I'm going to use my slope, which is 5/2, and I'm going to go up 5. 1, 2, 3, 4, 5, and over 2. Well, I don't have enough room to do another point, so I'm gonna go backwards. That means you're gonna go down and to the left. A negative over a negative will create that positive slope. So 1, 2, 3, 4, 5, and left 2. Solid or dotted? Okay? Now look, if you don't like my shortcut, then you need to pick a point. Okay? If you don't like my shortcut, pick a point. The shortcut is put your finger on where it crosses the y-axis. And then you have to read this statement right here. Okay? This statement. Now listen to me. If you forgot to flip the sign, are you fixing to mess up?
Yes.
If you fixing to get it wrong. Okay? So, y's, I want the y's that are greater than. Where's greater than? Above my finger or below it? Above, and so that would be shading to the left. Okay? Now, can I do this on a calculator?
Yes.
Can I check it on a calculator? Yes. Okay, so let me make sure you know how to check it on your calculator. I'll do this one on my calculator, okay? Now look, if I'm checking it on a calculator and you didn't flip the sign, will yours be right on the calculator? No, okay? You gotta do something, people. All right? So y is equal to 5/2. You could use the fraction button if you wanted to. X plus 2. And then I'm gonna go over here. Some people do it first, but I don't. Never, ever. So I don't know. Anyway, I'm gonna go over here. If you're on my calculators, they're not fancy like this guy, and it doesn't have colors. It'll just be that line, and the line will start blinking on and off. And then you press enter. And all you're gonna do on my calculators is just keep pressing enter. This calculator's fancy, so he lets me change the color, but I'm gonna go down here. And here's what's gonna happen. When I press the enter button, I think, no, sorry. When I press the left or right key, because since that's what it's blinking on, I thought this morning I pressed the enter button, but it didn't let me. Anyway, when I go to the right, it changed to a fat line. Well, that's not what I'm talking about, okay? Oh, look at there. Where did it shade? Above. What would that be? Greater than. Oh, I'm going to press it again. Ooh, it's shaded below. What would that be? Less than. And then it has these little cool things. Like this is called a tracer ball. All right? It's a little 0 with a little line in front of it. That means it's going to run across your graph and it would leave a trace where you left it. As opposed to this guy who just runs across your graph and then you have nothing left. Okay? And then this is a dotted line, and then I guess a lighter dotted line. I don't really know. Anyway, I want the greater than because that's what this says, greater than. Right? So I'll say okay and graph. And I'm looking for the purple guy. And boom, there he is. Okay? Anybody got a question? Okay, I got one more I want you to work and then I'm done. And then you can work on your worksheet for just a little bit and see if you have any questions or anything. Some of the other kids had questions in the other class, so I wanna give you some time. So here we go. This one ought to take about less than a minute. Y is greater than -2 times the absolute value of x minus 3 plus 4. Can we put the timer on you?
No, wait a minute, I write
Yes,
slow.
ma'am.
I have to make my graph.
I know, but see, you gotta learn how to perform under pressure.
Oh, easy there. Pressure.
Should have the Jeopardy song playing. Now, on these right here, don't write the slope and the y-intercept, because that irritates me, okay? I'm okay for the slope, but people call this the y-intercept. People, please, it is not the y-intercept, okay? It is not the y-intercept. If you do it and you wanna know if it's right, check it on your calculator, people. Okay, so remember, x's are weird and y's are not. X's are weird and y's are not. What does this negative do to, first of all, it's an absolute value, people. What had it better look like? A V. If it's not a V, it's wrong. It's wrong, it's wrong, it's wrong. Okay? So what does this negative do? What's that negative do to my
It
V?
goes to the right.
Oh,
What
it
is
goes
this
out.
thing?
I'm sorry, I was looking at the middle one.
What does this negative
Oh,
do?
it flips it upside down.
Yeah, it was like this, okay, and now he's like this, all right? And then this is my slope, all right? So he's gonna go down 2 and to the right 1 and to the left 1. What does this minus 3 do? Moves him where? To the right 3. 1, 2, 3. What does this plus 4 do to him?
Moves it up forward.
1, 2, 3, 4.
Ah.
Okay, so there's my vertex. All right, my other 2 points come from this slope. So I'm gonna go down 2 and to the right 1 and to the left 1. How many points do I have to have? 3. There they are, people, okay? Now I'm gonna make it, is it solid or dotted?
It's dotted.
That'll cost you a point if you made it solid, okay? Now, you're either gonna shade inside the V or outside the V. That's your only choice, okay? You're either shading inside the V or outside the V. I love my rule because it works here. It works everywhere. It's amazing, all right? So I put my finger on where it crosses the y-axis, and it says, I want the y's that are greater than. Would that be above my finger or below my finger? Above. Is that inside or outside?
Outside.
Everything outside.
Okay, so there it is. Anybody got a question?
No.
All right, so I want you to take this last 10 minutes, perfect, and I want you to work on your worksheet. You have all your worksheets. So the next time I see you guys, Friday, you will have a test, okay? You will have a test. I'm going to, I'll tell you what, I'll be here, I'll be back Thursday, and I will have your 2.4 graded and in the box. If you want to come in sometime, you don't even have to say anything to me. Most of the time I leave my door open, you can just step right in, look in your box, find your paper, and be on about your business, okay? Huh?
Please, restroom.